Welcome all of you dear guys. Extremely fantastic rainy evening today. Today is a lecture number 5 as long as wave optics is concerned. And in this lecture we want to discuss reflection of light at a plane surface in our most favorite YouTube channel Physics Make It Simple. So before learning directly, observe the ray diagram at first, dear student. See the ray diagram. The ray diagram, these P and Q are the incident rays. AB is a plane wavefront. Where is source? Since AB is a plane wavefront, we know for obtaining the plane wavefront, source is at infinity. That I have written here. Source is at infinity. So AB is an incident plane wavefront. PQ is incident rays. RS, see RS. RS are called as reflected rays. RS are reflected rays. We know this is incident angle I, this is reflected angle R. In a similar manner, here is also incident angle I and reflected angle R. This FE, this FE is what? It is a reflected plane wavefront. It is FE is a reflected plane wavefront because this FE is bounded between two reflected rays RS. MN are the imaginary perpendicular lines, we call it as normal. That is normal. C is the velocity of light in air, and we know CT is the distance travelled by the light in time t, we call it as CT. So this is all about ray diagram. Then we have to learn now the explanation. How the explanation is? We will make it very simple for your understanding, for your examination point of view. How we can write the note? See here, the first sentence is source is at infinity. Consider a plane wavefront AB which is bounded by two incident rays P and Q. Okay, when this incident plane wavefront come here like this, so point A reaches the point C, at the same time simultaneously point B reaches the point D. Okay, as long as the C touches the reflecting surface, listen carefully, as long as the C point touches the reflecting surface, what happens? According to Huygens principle, this C point acts as a secondary source, sending out secondary waves in forward direction, covering a distance equal to CT, that is CF, to produce spherical wavefront as shown in the figure denoted by this red half circle. This is a spherical wavefront created by the C point. As soon as, I will repeat again, as soon as C point touches the reflecting surface XY, according to Huygens principle, C acts as a secondary source, sending out secondary waves in forward direction, covering a distance equal to CF, which is equal to CT, to produce spherical wavefront as shown in the figure. When C reaches to F, covering a distance equal to CT, at the same time, listen carefully, that D point reaches to E point. D point reaches to E point. Then only the one thing that you have to do, draw the tangent FE. This tangent suggests the reflected plane wavefront because this FE is bounded by two reflected rays RS. So this is the so much sufficient explanation for the reflection of light at a plane surface. Whatever I am discussing with you, that all points I have already written on the board for your understanding. So read that points carefully after finishing my lecture, and then we have to do some calculation. To do the calculation, observe the two triangles. Which are the two triangles? CFE, this is one triangle, and another triangle is CDE. Then comparing these two triangles, what we get, that is most important. The first point we get is CE is a common length. CE is a common side. Length of CE is common for two triangles. Then when D reaches to E when C reaches to F at the same time, D reaches to E. For calculating the ray diagram, measure this distance in a compass and that point is kept here and draw a half circle like this by measuring this distance. That means this CF will become DE. So CF is equal to DE, that I have written here. Length of CF is equal to length of DE is equal to CT. That's all. So we get rectangle here and here. 90-degree angle in both the triangles. So one angle is equal and which is equal to 90 degree. Angle CFE equal to angle CDE which is equal to 90 degree. CE is common, length of CE is common for both the triangles. And one thing that I have already told you, length of CF is equal to length of DE is equal to CT. So these three conditions are satisfied. When these three conditions are satisfied, then that two triangles are called as congruent triangles. That two triangles are called as congruent triangles, and when these two triangles are congruent triangles, their front angles are equal. That is a rule. That is a rule suggested by the geometry. So if this angle is R, this angle is 90 degree. See here, this angle is 90 degree. Out of that, this angle is R. Then remaining this angle is 90 minus R. See here, this angle is 90 degree. This angle is 90 degree. Out of that, this angle is I. So remaining angle is 90 minus I. These two are the front angles. And since the triangles are congruent, their front angles are equal. And so that we have written 90 minus R is equal to 90 minus I because of having congruent triangles. And as long as 90 minus R is equal to angle 90 minus I, we can write angle I is equal to angle R. Incident angle is equal to reflected angle. So this result we will write in a remark column. So I have written remark here. The first remark is incident angle I is equal to reflected angle R. And another most important thing is that incident rays, reflected rays and normal lie in the same plane. These are the two remarks we got, and these two remarks together we call it as laws of reflection. Laws of reflection. Incident angle is equal to reflected angle. This is the first remark. The second remark is that incident rays, reflected rays and normal lie in the same plane. These two remarks together we call it as laws of reflection. What type of question is to be asked? As long as various examination point of view, the question is like this: derive laws of reflection of light using Huygens principle. Or another 2 marks question, there may be a possibility of asking the question like this: draw a neat labeled ray diagram of reflection of light at a plane surface, or draw a neat labeled ray diagram of reflection of plane wavefront at reflecting surface. So that is all about reflection. So up to this it is most sufficient, and we will meet again in the next lecture. Goodbye.